Today we are going to see about LCR circuit, inductance, resistance, capacitance circuit connected in an alternating voltage. LCR circuit. You'll have L, inductor, capacitor, resistor, which is connected to an alternating circuit. LCR. This is alternating voltage we apply. Generally, you all know that this LCR circuit is used in TV, radio, in defense for detecting signals of different frequencies. Here, this combination of LCR connected to an alternating current produces oscillations, and these oscillations can be changed from time to time by changing the values of inductance, capacitance or resistance. In this circuit, the resistance offers an opposing force to the flow of current, alternating current. Also, the inductance gives a opposing force to the flow of current, and that resistance given by an inductor to the flow of current is called inductive reactance, X suffix L. The capacitance also gives a opposing force to the flow of current, and that resistance given by the capacitance is called capacitive reactance, X suffix C. This R is R because the resistance given by the resistance is resistance itself. So here you get the opposing forces as inductive reactance, capacitive reactance and resistance. So we get a net resultant opposition or resistance to the flow of current. We call it as impedance of the circuit, which is denoted by Z, and is calculated as R square plus XL minus XC the whole square, the whole root. So the total impedance is called Z. And the voltage supplied by the alternating voltage will be dropped across the resistance, inductance and capacitance. So the voltage drop across this inductor is called VL. Voltage drop across the capacitor is called VC, and the voltage drop across VR or resistance is called VR. Suppose if you want to calculate the net voltage, there is another formula. V is equal to VR square plus VL minus VC the whole square, the whole root. Using this formula, we can calculate the net voltage supply in the circuit. Now, we are going to apply this theory to solve some JEE questions or higher order thinking questions. Today in this video, I will show an application of this LCR circuit, how you have to manipulate and arrive at the answer when these kind of higher order thinking questions or JEE questions are asked. Here, in this, say, the voltage is given as 200 volts with a frequency of 50 Hertz, because alternating voltage has cycles, positive and negative cycles. So here 200 volt is applied, 50 Hertz is the frequency. In case if you imagine, or if it is given in the problem, the voltage drop across this is 100 volt and across the inductor is 100 volt and across the capacitor is 100 volt, and they are asking you to find the potential drop across the resistance. How to find it? You have to use this formula. You just square this formula. You will get VR square is equal to, V square is equal to VR square plus VL minus VC the whole square. And now substitute the values, taking VR to one side. So VR square is equal to V square minus VL minus VC the whole square. So if you substitute the values, this is 200 square minus 100 minus 100. 100 minus 100 is 0. Now the left is VR square. VR square is 200. So what is VR? If you take the root, it will be 200. So this is how you have to find these answers for the questions. Generally they will give you the voltage for including the main voltage, and one voltage across some component will be left out, you will be asked to calculate. Sometimes they will ask you to calculate the current flowing through the resistor. Say for example, if the resistance value is given as, R is given as 200 ohms. If the resistance value is given as 200 ohms, then how to calculate the current? They have to calculate it using Ohm's law. I is equal to V by R. So the voltage we have found across the resistor to be 200, and the resistance value is given as, resistance value is given as 200, and so the current will be 1 ampere. So you can also find the current in the circuit using